Namaskar, I'm Harpreet Kaur and I welcome you all to this wonderful session of ours presented to you by Department of Education in Science and Mathematics NCERT. Well, this is our wonderful webinar series titled Listening to Learn, yani Sunne aur Seekhe. And in this session, of course, we are going to take an amazing topic as this is the 108th edition of our webinar series, and the wonderful topic that we have taken up is amazing. It's about National Space Day. Yes, we are celebrating National Space Day in this edition of DESM, and it's going to be a journey to our nearest star, the Sun, with AdityaL1Observatory. This is a session that is, of course, being telecast on PME Vidya channels 9, 10, 11 and 12 and on our YouTube handle NCERT Official. Since it's going to be one wonderful journey, we would like to have your feedback as well. So you can definitely post your feedback on our YouTube handle NCERT Official. You can give us a call and you can write an email to us. Email ID is of course dth.class12@cit.nic.in. Please, it's a polite reminder to everybody that participation certificates will be issued to those who will definitely post their feedback and comments on our YouTube handle NCERT Official. Now, in this webinar series, we have brought some amazing topics for you so far. In case you want to watch our previous sessions, you can go to a particular link which is ncert.nic.in/webinar_series.php. We all know that 23rd of August is celebrated as National Space Day in India. And when we talk about such celebrations, we can say that, they serve as a reminder of the country's growing capabilities in space research and its commitment to furthering scientific knowledge. It also highlights the importance of space technology in our everyday life, from communications to entertainment to education to weather forecasting and whatnot. So let's go and venture into this beautiful space odyssey of ours. We are joined by two eminent personalities and I'm going to introduce you all to the man behind this entire initiative. Please join me in welcoming Professor Gagan Gupta from DESM NCERT. Sir, namaskar and very warm welcome to you.
नमस्ते हरप्रीत, नमस्ते साथियों। आज का दिन 23 अगस्त 2025 जिसको कि हम नेशनल स्पेस डे की तरह से मना रहे हैं। साथियों, आपको याद होगा कि हमने 2021 में जब से ये सीरीज़ को स्टार्ट किया, हमने विभिन्न विषयों पर बात की। हमने स्पेस से जुड़े हुए विषयों पर भी बात की, प्लैनेटरी मिशन से जुड़े हुए विषयों पर बात की। मेरे साथी हरप्रीत ने अभी बताया जैसे कि पुराने सारे सेशंस आप हमारे NCERT वेबसाइट पर देख सकते हैं। मैं एक और तरीका आपको बताता हूं, आप हमारी NCERT.nic.in वेबसाइट पर जाएं, वहाँ उसके इवेंट सेक्शन में जाएं। इवेंट सेक्शन में आपको वेबसाइट इस वेबिनार सीरीज़ का लिंक मिलेगा, उस लिंक को क्लिक करें, तब आप देखेंगे कि हमारे बहुत सारे सेशंस सन 2021, नवंबर 2021, जनवरी 2022, मार्च 2022, जनवरी 2023 और 2024 के कई सारे सेशंस में, जिसमें कि हमने स्पेस से जुड़े हुए विषयों पर बात की है। हमारे साथ आज इंडियन इंस्टीट्यूट ऑफ स्पेस साइंस एंड टेक्नोलॉजी के वाइस चांसलर प्रोफेसर दीपांकर बनर्जी हमारे साथ हैं। IIST से हमारा बहुत पुराना रिश्ता रहा है, हमारा बहुत पुराना संबंध रहा है। पूर्व में भी IIST के प्रोफेसर आनंद हमारे साथ रहे हैं इस सेशन में। उन्होंने भी हमसे जेम्स वेब टेलीस्कोप पर बात की थी। वो बात थी जहाँ पर कि सितारे टिमटिमाते हुए नहीं दिखते हैं। आज हम अपने नियरेस्ट स्टार के बारे में बात करेंगे, हम अपने सोलर सिस्टम की बात करेंगे, हम अपने सन की बारे में बात करेंगे, और जिसको कि AdityaL1 ऑब्जर्वेटरी के साथ हम देख रहे हैं। इसके बारे में मेरे साथी प्रोफेसर दीपांकर बनर्जी अभी आपको बहुत विस्तार से समझाएंगे। स्पेस मिशंस के बारे में हमने बहुत बातें की हैं। आप इन सारे सेशंस को आप हमारी वेबसाइट पर देख सकते हैं, NCERT ऑफिशियल चैनल पर देख सकते हैं। आज का प्रोग्राम इस मामले में बहुत अहम है साथियों। 23 अगस्त ये वो दिन है जिस दिन कि हमारे चंद्रयान 3 से विक्रम लैंडर उतरा था और सॉफ्ट लैंडिंग हुई थी और हम चंद्रमा पर पहुंचे थे। चंद्रमा पर, और हम बहुत प्रमुख देश बने जिन्होंने कि चंद्रमा पर लैंड किया और चंद्रमा के साउथ पोल पर पहुंचने वाले हम पहले देश बने। साथियों, तो इससे पहले कि मैं प्रोफेसर दीपांकर बनर्जी, आपका हमारे इस प्रोग्राम में बहुत बहुत स्वागत है। और आप मैं साथ साथ आपका और इंडियन इंस्टीट्यूट ऑफ स्पेस साइंस एंड टेक्नोलॉजी और डिपार्टमेंट ऑफ स्पेस सबका बहुत धन्यवाद ज्ञापित करता हूं, अपने पर्सनल बिहाफ पर भी और NCERT के बिहाफ पर भी। आज आप हमारे साथ त्रिवेंद्रम से जुड़ रहे हैं, बट मैं उम्मीद करता हूं कि बहुत जल्दी ही हम एक बार पुनः अपने स्टूडियो में फिर से मिल पाएंगे और जिस पर जबकि हम आपसे ज़्यादा बात करेंगे। आज साथियों, मैं आप इससे पहले कि प्रोफेसर दीपांकर बनर्जी को मैं आपके साथ लाऊं, मैं उनके बारे में आपको कुछ बताना चाहता हूं। प्रोफेसर दीपांकर बनर्जी, हु इज़ ए सीनियर प्रोफेसर at the Indian Institute of Astrophysics, Bengaluru, joined the Indian Institute of Space Science and Technology, Thiruvananthapuram, in October 2024 as its Vice Chancellor. He holds the bachelor's and master's degree from the Xavier College, University of Kolkata. He also holds the PhD in astrophysics from the Indian Institute of Astrophysics, Bengaluru. This is the place where he is permanently settled as a senior professor. Prior to joining IIST, Dr. Banerjee has been the director of Aryabhatta Research Institute of Observational Sciences, Nainital, popularly called ARIES, during 2019 to 2024. Research interests of Professor Banerjee include the sun and the solar atmosphere. His work involves theoretical and numerical modeling using data from ground and space-based instruments. His work has enriched our understanding of the sun and its impact on space weather. He is the co-chair of the science working group of the Aditya mission. Aditya is the first dedicated Indian mission to study the sun, launched by ISRO on 2nd of September 2023. He is also involved with the NASA's PUNCH, that is polarimeter, to unify the corona and heliosphere mission. Dr. Banerjee is the fellow of Indian Academy of Sciences, National Science Academy and Royal Astronomical Society. He is also the immediate past president of the Astronomical Society of India. Dr. Banerjee is a very well renowned scientist of the country who has published more than 150 peer reviewed articles and has also supervised around 20 PhD theses, out of which 15 have already been awarded, 5 are underway. Very interestingly, Dr. Dipankar Banerjee, besides his scientific career, has interest in various other activities too. He is trained in Hindustani vocal and part of a Bengali theatre group, Samaranik. He also regularly performs in plays. We look forward participating in national and international theatre festivals. Dr. Banerjee's love for science and zest for life are indeed infectious. Professor Banerjee, it's all yours now. Once again, we thank you for having collaboration with NCERT for the program. Please, it's all yours, Professor Banerjee.
Thank you very much, Professor Gupta, for your very kind introduction and providing me this opportunity on the NCERT platform, because we scientists want to connect with the younger minds, and you are providing us this platform to connect with the larger scientific minds. I'm very, very thankful to you for this opportunity. So today I will be telling you a little story about our journey to Lagrange 1, which is about 1.5 million kilometer away from Earth. But before I go, I should also first point out that this is a major science mission from India, and as you can imagine, there are a number of institutions in academic fraternity, and also different ISRO centers been very intimately involved with this mission for more than decades. So I will not have time to go through all the different institutions, their names, but the logo of these several institutions give you an impression that this is a perfect example of our Atmanirbhar Bharat, because this mission is indigenously developed and 100% been built in India. So they can also say it as a make in India demonstration as well. So before I go to this journey, I will also take this opportunity to introduce to this institute called Indian Institute of Space Science and Technology, situated in Thiruvananthapuram. Since I'm talking to the students, so I would really love to give a very quick journey to this campus at Vailimela at Thiruvananthapuram. I'd also like to point out that Indian Institute of Space Science, and Technology Institute is a unique university which really caters to the demands of our space department. So it was constituted in 2007 for the need of Indian space program, and we have a beautiful campus, and the students are enrolled from all over the country. JEE Advanced, route. So if you qualify through JEE Advanced, along with Indian Institute of Technologies, you can also choose one of as IIST as your destination. So it's just giving a glimpse of the institute and its facility. It's a beautiful hill, Punmudi in our neighborhood. We have a climate observatory at the hill top as well. We do have our own space small satellite program. We have our ground station. So the students participate in instrument building, and and subsequently they join ISRO. So we do run BTech programs in aerospace, then ECE and computer science and data science. We also have a dual degree program, and we done several master's program, and of course PhD program. So it is an ideal institute for really nurturing space science and technology. We have a combination of engineering department and physics, chemistry, maths, and humanities department for a comprehensive training of undergraduate and postgraduate students. So students, please feel free to contact me if you are interested about this institute and its admissions and so on. So with that background, I will also like to again point out today's auspicious day as far as space scientists are concerned. So we are, the significance is we commemorate the Chandrayaan-3 successful landing near the moon's south pole in a couple of years back now, and we celebrate this flagship event also at Bharat Mandapam in New Delhi with several sessions, exhibitions, and there are also ISRO-led programs including Space on Wheels and Space Tutors. So if you have not been able to participate in this year, please keep your options open or eyes open for next year's activity. And a lot of these activities which are across the country through lectures, workshops and quizzes, as I'm doing.
Right. I think so. This wonderful PPT shows about the sun, a star. You can throw more light on it.
Yes, there is some network issue at the moment, but don't worry. The starts. Say 23rd of August is a very auspicious day, as my friend Dipankar Banerjee was speaking regularly. So India is going to have large celebrations. This year celebrations are more important.
Okay.
Because one Indian has been on Indian space station, and then group captain Subhanshu Shukla will also be with us in Delhi for. Shall we stop?
Right. And
right. So we will be celebrating in a great way at Bharat Mandapam this year. Professor Banerjee will also be there. He is also there.
And so, what about this National Space Day? I think it's a very big achievement for India.
Yes, India started its space program in 1962 through the INCOSPAR, and then ISRO subsumed this INCOSPAR in 1969, and to commemorate all
different parts of the sun. So today's lecture, you will see that how many different observations we have now, and our Aditya own mission is now giving us all these different images. allowing us to see the different structures of the sun. Of course, it is a special star because it provides almost all the energy to the Earth. Our existence is because of the presence of the sun. And from the physics point of view, like, I have also studied mostly physics in my undergraduate, postgraduate program, and I could see that the sun is a very special laboratory where I can apply my knowledge of atomic physics, nuclear physics, any branch of physics you actually name it, you can, see that this is applicable in the case of the sun. So we can't really see inside the sun, but through certain knowledge, we have some information about the interior of the sun. So if I could see inside, then we now know that there is right in the center of this huge spherical ball, which is the sun, where the energy is created, and there is some nuclear reactions are happening, and then it burns hydrogen and it forms helium, and a huge amount of energy is radiated out. So this is called the core of the sun, where these thermonuclear reactions happening. Then we have a radiative zone where the energy is primarily propagated by radiation, and the 30% inside the sun, the energy is propagated by a process called convection. You know that when you start boiling a soup, initially, the temperature on the top and the bottom is same, but as you supply the heat from the bottom layer, then convection starts in the hot objects goes to the top, and the cold liquid goes to the bottom, and then convection sets in. So similarly, within the sun, underneath these 30% of the layer, we have this convection, just like a boiling soup, and energy is propagated through this process. Now, the other very interesting aspect of the sun is, we think that the sun is there and it is always radiating the same amount of energy, and nothing huge changes are happening, but that is not true. Actually, on the sun there are these kind of huge structures. They undergo a lot of changes. So here I am showing you again an image taken from a NASA satellite called Solar Dynamic Observatory, looking at the portion of the sun. And if you can focus on this region where my cursor is, see, there are these regions are brighter as compared to the other portion of the sun. These portions are covered by strong presence of magnetic field. Now we know that the magnetic field plays a crucial role in the dynamics of these structures. Here you see a portion of these magnetic structures, they become unstable and they explode, and a huge amount of energy and material is thrown into the interplanetary space. So these are called solar storms, and these magnetic regions underneath, they are called sunspots. So sunspots are nothing but locations on the surface of the sun which has presence of strong magnetic field. And that's why presence of the magnetic field also confines lots of plasma. It often forms in the form of these kind of huge circular structures. They are called coronal loops, because this image, what we are seeing is actually atmosphere of the sun. We name it as corona. I will go a little more details about what are really the solar corona is. So what I wanted to highlight here, that there are variability of different time scales on this sun. So this explosion is happening within few hours to minutes kind of time scales. So that kind of huge explosions or storms will emit lot of particles, energy, which will travel to the interplanetary space and will travel everywhere. And if we are in that direction, then we will be impacted by these highly energetic particles which is coming from the sun. So I will later on say what is the impact of that. So that is a kind of variability which is time scales of few hours to days. Whereas what is plotted here now is yearly sunspot number for last 400 years. As I pointed out, that the sunspots are the regions where there is a strong presence of magnetic field. So the magnetic variability of sun is measured or estimated by this number called sunspot. When there are lots of sunspots, we call sun is magnetically very active. So here, if you look at these, variations from all the way from, early 1600 to 2000, you see that there is an alteration of the sunspot number. We call this as a solar cycle. There are periods over which there are lots of sunspots, and there are periods over there are very few sunspots or no sunspots at all. Between 1650 to 1700, there were hardly any sunspots recorded by the small telescopes, whatever we had at those years. What was the implication of that? If there were no sunspot, it appeared that the Earth was extremely cold. In the Western world, there is a river called Volga, which runs across a different part of the continent of Europe. It was frozen for 40 years. People were actually skating in England in the Thames River, on the river itself, because it was frozen for so many years. So that means if sun becomes suddenly less magnetically active, then it will have a huge impact on our climate. So this is again another very important aspect of studying our climate, long-term climatic change, because of the changes happening in the sun. So this is one more important area. Why do we need to study sun on a regular basis in a short time scale, in long time scale as well? So this is called the solar cycle, and it has a lot of impact on our climate, as I mentioned. So again, I'm showing you, dynamic behaviors which are of shorter time scales happening all the time in the sun. Here again, another movie taken from the Solar Dynamic Observatory. You see that these huge structures we called prominences, and these structures, because of certain instability, they have exploded, and all these material has traveled into the interplanetary space. But so then, how do we follow these material as it travels? So we need instruments to really follow close to the sun, and as it goes away from the sun as well. So this is again a full disk image of the sun, what you can see here, and then you see when the material is going out, away from the sun, some material again going back to the sun and creating lots of disturbances on the different layers. So now to follow these huge explosions, we also sometimes block the solar disk. This is very similar to the total solar eclipse kind of scenario. We call these instruments as coronagraph, and in fact in our Aditya mission, we have similar instruments called coronagraph, and we capture the motions of these huge explosions as it leaves from the sun before it can reach our near-Earth environment. So here again another movie shown from the Parker Solar Probe. This is again one of the our generation's best achievement in terms of space journey. Parker Solar Probe is a NASA satellite which is really traveling much closer to the sun. We have gone only to 1% distance between the sun and the Earth through the Aditya mission at Lagrange 1, but this Parker Solar Probe is really traveling to 70% distance closer to the sun. That's why it is not even looking at the sun, it is looking away from the sun and trying to really image and see the properties of these huge explosions of the solar storms as it comes from. So these kind of new observations are really revealing a new story altogether, that these storms which is happening in space because of the explosions in the sun are really harmful for our near space environment. Why? Because we are so much dependent on the space. Today we have satellites for our communication system, we have satellites for our surveillance system. As if the satellites get damaged, our daily life gets disrupted. Our communications get disrupted. Your WhatsApp will not be delivered. You are in the middle of a forest. Your mobile phones, we are going to use the satellite communications directly for mobile usage. It will not work if the satellite gets damaged. And as you saw from my previous movies, that there are so much of storms happening on the solar atmosphere. Those storms are directly actually impacting all the space assets. You heard this recently, Shuklaji is just back in India. Shuklaji was traveling to International Space Station. If such a storm happens, you can directly imagine it will be very harmful if Shuklaji is at that time International Space Station, just traveling outside somewhere, doing some experiments and so on. So whether it is astronaut safety, whether it is directly the satellite, and then there are all these, ionosphere, which is very, very important for our communication. So the ionosphere also gets, disturbed when such, storms hit the ionosphere. And when ionosphere gets disturbed, our communications, even the communication which needs the ionosphere for reflection, we communicate between different parts of the globe by sending some signal to to the sky, and then that it gets reflected, and then the other part of the receiver in other part of the globe communicates. So our ground-based communications, even through using ionospheric atmospheric layers, also gets directly affected. So there are many such susceptible sectors. Our telecommunication, GPS, we all need GPS. Our long haul flights these days, if you want to take a flight from Delhi all the way to New York, it doesn't go through Europe, it goes through the polar region. And when it travels to the polar regions, actually it is much even more exposed to these particles, simply because Earth has its own magnetic field. So we are existing here because Earth magnetic field actually prepares a cocoon, and we are inside this cocoon. If Earth did not have magnetic field, we would not have survived. In fact, now you're also here, we search for life in other planets, not only in our solar system, beyond anywhere in the universe. We have discovered 5,000 odd planets in other stellar systems, but still we have not found any life. We are searching for it. But whether life will exist or not, first thing will be that whether that particular planet has magnetic field or not. So within our solar system also, we are doing other planetary missions, and one of the major factor whether the planet has its atmosphere and will have presence of certain elements and all that, all depends on whether that planet will have magnetic field or not. So that way it is very, very important for us to understand this magnetic interaction from the sun. This huge ejecta, we call it coronal mass ejections, they carry particles, they carry also magnetic field. And when these huge magnetic storms, we sometimes call them as magnetic clouds, they interact with Earth's magnetic field environment, there is a lot of disturbances as well. So space weather is this new field which is really, really affecting our global technology. So that's the reason we need to understand the sun behavior. So with that background about why do we need to study the sun, we were fortunate in our lifetime that we could manage to get our own space mission, and it was launched on September 22nd. And this is a short movie which will give you this idea about our mission, the integration.
AdityaL1 spacecraft being prepared and ensconced into a protective container where the environment is controlled and the temperature is controlled, the cleanliness is controlled. At the vehicle assembly building, again, there is a clean room provision to safely integrate it to the rocket, and then the heat shield halves are closed. Now the vehicle is fully ready to be moved to the launch pad, which is about 900 meters away. This is PSL. The mission intends to place the spacecraft in 235 by 19,500 kilometers orbit with an inclination of 19.2 degrees. The total mission duration.
You can actually visit the chart for viewing all these launches as well. So now you see the countdown has started.
AdityaL1 सूर्य का अध्ययन 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Yeah, the successful launch. We were all inside the control center.
Just 5 seconds. Liftoff. You are tracking? Tracking.
Magnificent liftoff of PSLV C-57 with AdityaL1 on board.
Plus 15 seconds. PSLV C-57 का सफल उत्थापन और इसके साथ 20 seconds. प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के तेज से विज्ञान को प्रकाश करने।
Air lead strap on ignited.
इसके साथ ही एक और कदम है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV C-57 प्रथम चरण पूरी तरह सामान्य है.
The rocket flying forth, following nominal trajectory and developing nominal thrust. The bright fumes against a clear midday sky. The rocket first stage S139.
So there are different stages of a rocket, of the spacecraft. So here you see now from the control center.
ग्राउंड लेड स्ट्रैप ऑन को सेपरेट कर दिया गया है और प्रथम चरण का निष्पादन सामान्य है. इस घटनाक्रम में अगला एयर लेड स्ट्रैप ऑन को यान से पृथक कर दिया जाएगा.
Air lead strap on separated.
3 मिनट्स. वर्तमान में यान क्लोज लूप गाइडेंस के अंतर्गत है.
Second stage performance normal.
यान की ऊंचाई 106 किलोमीटर तथा सापेक्ष गति 3
Going to be from 2 kilometers per second to 4.9 kilometers per second.
और तृतीय चरण जो कि ठोस नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है.
This is the third stage.
We are close to 5 minutes past the launch mathematical computation to calculate present and future location of the spacecraft in a process known as orbit determination.
So there are different stages, as you saw in that movie, and then the final separation happened almost an hour, because this was a very, very unique, mission. And first time we reached there. So the clever way we actually achieved this mission. So here you see we did five Earth-centered orbit transfer, and then we had a cruise phase of several months, and then final insertion there. So Lagrange 1 is actually a fictitious point. It is an imaginary point in space where there are certain, force balances are there. So here, if you reach Lagrange 1, for any orbit, what you need is a force. We call it a central force, and that force is provided by the force balance between the satellite and the Earth, and the satellite and the Sun. So we are, of course, Sun is much, much heavier and much away as well. So we are about 1% of the distance between the Sun and the Earth. So anything happening on the Sun before it reaches Earth, it has to come through this Lagrange 1 and around that location. So being present here, we are able to continuously view the Sun and also study all these explosions which is coming from the Sun. So that was the first signal which we detected even from one of the particle detector instruments here when it was orbiting around this near Earth center orbit. And as I pointed out, that first week of January, we had this very successful L1 insertion, because this is quite a challenging task. When we were going to Mangal mission, at least of course you have to slow down and they have to get into the gravity of the Mars. But here it is even more challenging because there is no object here. So you have to have a precise, simulation which has to match with all the control systems of slowing down and insertion in the hello orbit. And this was so precisely done, and we are really, really proud to be an Indian that with our, our technological advancement, we are the fourth nation in the universe. We could, successfully go there within our again first attempt as well. Again, there is a small little movie about the different scientific payloads on Aditya.
The AdityaL1 mission carries a suite of 7 scientific payloads to carry out systematic study of the Sun. The Visible Emission Line Coronagraph, VELC, studies the solar corona and dynamics of coronal mass ejections. The Solar Ultraviolet Imaging Telescope, SUIT payload, images the solar disk in near ultraviolet and also measures the solar irradiance variations. The Aditya Solar Wind Particle Experiment, Aspects and Plasma Analyzer Package for Aditya, PAPA payloads study the solar wind and energetic ions, as well as their energy distribution. The Solar Low Energy X-ray Spectrometer, SOLEXUS, and the High Energy L1 Orbiting X-ray Spectrometer, Helios, study the X-ray flares from Sun over a wide energy range. The magnetometer payload is intended to measure the interplanetary magnetic field at the L1 point. The science payloads of Aditya L1 are indigenously developed by different laboratories in the country. VELC is developed at the Indian Institute of Astrophysics, Bengaluru, Suit Instrument at Inter-University Center for Astronomy and Astrophysics, Pune. Aspects Instrument at Physical Research Laboratory, Ahmedabad. Papa Payload at Space Physics Laboratory, Vikram Sarabhai Space Center, Thiruvananthapuram. Solexis and Helios payloads at UR Rao Satellite Center, Bengaluru, and the magnetometer payload at the Laboratory for Electro-Optic Systems, URSC.
So this suite of instruments we call is a combination of remote sensing and in situ, because we are at around Lagrange 1 location, and as I pointed out already, that Earth has its own magnetic field, but because of these continuous particle which is coming from the sun, we also have a continuous outflow of material from the sun. We call it solar wind. That modifies the magnetic field behavior near the Earth. So here you see that, as I was mentioning, that we live in Earth essentially by a magnetic shield or magnetic cocoon, and we are protected from these huge particles and magnetic field which is coming from the sun by this process. So before it reaches Earth, what we are planning to do is, or what we are doing right now is, we have several instruments to look at the sun in the ultraviolet. We call it solar ultraviolet imaging telescope. We have a coronagraph. We block the solar disk light, and then that we image the environment of the atmosphere, outer atmosphere of the sun, which is called the corona. Then we have two X-ray spectrometers. We look at their spectrum. That means when such huge explosion happen, we call them solar flares. And those solar flares, when they they are happening, how much energy really is emitted, depending on the low or the high energy content of these flares, the impact of these flares, the energy particle carrying what sort of material, what sort of ionization state, and all that can be remotely observed. And when they arrive before reaching Earth, will they pass through Lagrange? We have particle instruments, namely the Papa aspects, and then they can characterize the properties of these energetic particles, what sort of charges they have, what sort of mass they have, what kind of magnetic field they are carrying. That can be again tested or measured by this magnetometer. This will allow us to estimate the impact of the space weather when it reaches near Earth and when it impacts the space assets, namely the satellites or the International Space Station and so on. I will give you a very glimpse of our results, what we have so far. So this is the coronagraph movie which I am showing from our coronagraph instruments. This is all data is available in the public domain. So if if the students are interested, they can download the data. Of course, they need some training. For that also, we have regular training platforms. I will talk about it briefly there as well. So here we have this ultraviolet imaging telescope, which is a filter-based imaging instrument. We have 11 filters, which allows you to really see these different structures. As I said, these are called sunspots, and the surrounding areas of sunspots are called plages, and the other regions in the sun are called quiet sun. So with these different filters, we are able to probe different layers of the atmosphere of the sun. And here again, some example of these sunspot regions, and with other wavelengths, we can see slightly different structures of the atmosphere of the sun. And combining these different filter image, we will be able to really study the evolution of these structures at different atmospheric heights at different times and so on. So here again, this movie will give you indication that how these different atmospheric layers, so they are actually connected with each other by the presence of this magnetic field. So this instrument is allowing us to do this kind of study. Then when we are looking at outside the disk at the limb, we are able to capture these explosions on a very early stage. You saw earlier movies, from away from the sun, we had huge explosion. With the Aditya L1 mission, our instruments, we are really trying to look at very close to the sun, And here, when such explosion happens, the whatever change is happening and all that, their properties we are able to study with this suit instrument. As I pointed out, we have two X-ray instruments. They are also allowing us to study the spectrum of these X-ray energy bands in the low energy, and we are able to see these huge changes in the flux are indicative that there is a flare. And of course, we need to compare our results with the NASA satellites. We are capturing so many flares. Even we were so fortunate that last year in the month of May, normally flares do happen once in a few years. This particular huge strong flares, we call them X class, and we were so fortunate that we were able to capture so many X class flares because sun suddenly became very, very active. And that has affected a lot of space weather. There is damage, a lot of satellites and other things also. And we have been now studying these X-class flares, their properties, what kind of impact. So that was one, Solex, one instrument. Helios is working in slightly higher energy band, and Helios is also able to capture these kind of X-class flares. So a lot of new scientific, results are coming. This is the results from the magnetometer. As I indicated, when such a flare happens, it produces coronal mass ejection, and those CMEs, travel through the interplanetary space. Before reaching Earth, they will cross this Lagrange 1 location, and there, through these in situ measurements from the magnetometer, we are able to really see the kind of magnetic field that magnetic cloud is carrying. So you see normally the background interplanetary magnetic field is of this value. Suddenly there was a huge fluctuations. Basically they're capturing the content of this magnetic cloud, their magnetic field. This will allow us to really estimate that when that magnetic field, that magnetic cloud impacts Earth's atmosphere or space assets, what kind of impact or what kind of devastation it can create. So as I pointed out, that for AdityaL1 data, which is available from ISRO's ISSDC, online web portal, but then how to analyze this data and all that, we do, undertake a lot of these, training schools. So if you are interested in doing science in, a sort of undergraduate or postgraduate level, then you can participate and apply to these support cell workshops and then get trained. I also like to point out that, the space science experiments from India, we have started much later as compared to the other developed world. I'm just showing you how many satellites are there only for the studying heliophysics. What we call heliophysics is actually sun and the Earth and the entire solar system. We call it as a heliophysics because it is important to study the sun and its impact on Earth and other planets or even moon. So to have a comprehensive understanding of these, all the behavioral and the impact, we need many satellites. And this is just showing you that how many satellites are really dedicatedly studying sun and the heliophysics. 20 operating missions with different 27 spacecraft. We started late, but I think we started with a bang. So this is what I want to also say, that in India, I think we are very fortunate of this enormous opportunity what we have now with these big missions. And Aditya is a Lagrange 1 mission, is a really observatory class mission, because we have just not one instrument, we have 7 instruments with the multiple wavelength. As I indicated, we have X-ray, we have optical, we have infrared, we have ultraviolet. So this is really allowing us to get a comprehensive understanding of these phenomena which is happening in the sun and the near Earth environment as well. I will very briefly also point out that we are also participating in international program. This is a very unique experiment called PROVA 3. This is the European Space Agency's mission, and this was also launched by PSLV launcher in December last year. This is a very unique experiment. There are 2 satellites. They are in the formation flying mechanism. What is happening is, this is also very similar to our SpaceX experiment, if you have heard from ISRO, where 2 satellites were launched together, and then in space, this docking experiment was done. So they were separated, and then they were again, come together. We call it docking. because all these docking experiments and all that is very important for our participation in our own space station, for example, in the future, or you want to, do some servicing of a satellite. These are all futuristic direction which is required. We are thinking of, having satellites and then servicing the satellite in space. So how do you do it? Another satellite has to go into their proximity, and then they have to connect themselves. They have to transfer power. They can transfer certain elements also. So here this experiment is naturally creating an eclipse. So this particular satellite is blocking the solar disk light, and as you can see here, very similar to the total solar eclipse. During the total solar eclipse, the moon blocks the solar disk light, and if you are in the shadow region, the umbra of this shadow region, where the totality happens, then you see the outer atmosphere of the sun, mainly the corona. That is what artificially we call it a coronagraph instrument, because we can't wait for the total solar eclipse all the time to study the corona. So here, this particular mission is artificially blocking the solar disk light and creating this coronal images. So this is the first light coronal image. This instrument has made it in the public domain on 23rd May. And you can see that this green light coronal image, what we have is somewhat similar to our Aditya's own coronal image, the movie which I showed you earlier. So now we are actually doing some joint observation, because they have only imaging capability, we have spectroscopic capability. So we have complementarity in our mission. So that's how the science progresses, that you have to design certain instruments where there is some uniqueness, and then the rest of the world is doing something with some other capability, and then you combine this information to get a comprehensive understanding of this. So that's how the science progresses. I want to just share my own experience with this mission. I was fortunate enough to be in the launch side with this, with the project director and other, scientists from different ISRO and academic institutions. And this is a lifetime, achievement, you can say. You can also dream for participating in next ISRO's mission and contribute to better understanding of the universe as well. So thank you for your attention. I am happy for your for attention. I will be happy to answer any questions you may have, and you can additionally contact me also if you want to with this email address for future communication. Thank you for your attention.
Thank you very much, Professor Banerjee. We really enjoyed listening to you and seeing the movies and the visuals which you expressed. Now, see, I am receiving questions from different sides. There are some questions which are related with the sun directly, or some are with indirectly. I would try to focus my questions to you mainly to the sun or sun observations. So the first is with the Udaipur. See, we had Professor Bharadwaj here, Anil Bharadwaj, who spoke about this solar observatory program long ago. What is so special with the question is that what is so special with the Udaipur that we have the solar observatory there, and what is this gong? This is the question.
Okay, yeah, very good. So Udaipur Solar Observatory is actually situated in the middle of the lake. It is a ground-based telescope which is looking at again solar surface and low atmospheric heights, because from the ground we can only see the optical wavelength. We can't see the UV or X-ray wavelengths and all that. So for that reason, ground-based telescope do provide us a sufficient amount of information about the solar, again all these flares and these dynamics which is happening, but we can't see the higher layers of the atmosphere of the sun. The beauty of the Udaipur location is, for ground-based telescope, what happens is when the ground becomes very hot, then it affects actually the image quality. So when we look at any image of the say sun, because of the ground turbulence, because of the heat which is generated, it affects we call it solar seeing, that the transparency in the sky and these heat layers at different atmospheric height affects our solar quality image. Udaipur Solar Observatory has this telescope in the lake, and lake provides you a very cold, very steady atmosphere. So that is the beauty of that particular site, to have a ground-based telescope. So it has a 0.5 meter ground-based telescope which is looking at these flares and all that. So for low altitude, so there is another way to avoid these atmospheric seeing effects, is to go to the mountain. So that is why you see that majority of the astronomical telescopes are situated in the mountain. And since you asked this question, we have discovered a big lake in the mountain also, in the Ladakh region,
Yes.
called the Pangong Tso Lake. And in fact, from India, we have proposed a very large ground-based telescope in that lakeside in the mountain. So we will have a joint, advantage, having a lake for a very steady atmosphere, and also cold and high altitude means you have less clouds and those advantages. And the other question which you had was called GONG. GONG form is actually Global Oscillation Network Group. What happens when you are looking at the sun from any particular site in the earth? You see, sun rises and sun sets also. So we could only observe the sun for several hours, not the full 24 hours. Now, if you have exactly same instrument and same telescope at different locations across the globe at different longitude, then if you can combine the information what you are observing from, say, Udaipur, then one from say Europe, and then one in US, then you have a possibility of a continuous monitoring of the sun. So Global Oscillation Network Group has these 6 centers identified. This is a National Science Foundation, US fully funded project, which has placed one of those GONG telescope at Udaipur Solar Observatory. So India, through Physical Research Laboratory, and as you said, Professor Anil Bharadwaj, the director of the Physical Research Laboratory, he is primarily maintaining that Udaipur Solar Observatory as an independent observatory, and also as a partner to this GONG network. So these data immediately gets into the public domain through the NASA and NSF, as I indicated. It's funded by National Science Foundation. So it's actually a very, very profound international program, and it has produced thousands of scientific publications, and it's working for several decades now.
Yes, yes. You have answered many other questions too together with this. Now you talked about the spectroscopic capabilities which our AdityaL1 has. See, yes, we understand that there are many unknowns which we know, but there are much larger number of unknowns. So with this note, I like to, we are the students, Dr. Sahab, I hope you will appreciate कि हम साइंस के स्टूडेंट हैं, हम आँख खोल के सपने देखते हैं और उन सपनों से बात बनाने की कोशिश करते हैं. क्या हमारे L1 ने वहाँ पर आदित्य ने L1 पॉइंट के अराउंड क्या कुछ इस तरह का स्पेसिफिकेशन कर लिया कि जितने सन से जितने भी तरह के रेडिएशंस निकल रहे हैं उन सबको हम जान पाए हैं क्या अभी? बिकॉज द काइंड ऑफ इलेक्ट्रोमैग्नेटिक रेडिएशंस व्हिच वी नो is having limits.
You are absolutely right. You are absolutely right कि आप कुछ जानने का कोशिश करेंगे, जो आपको जानकारी नहीं है वो जो unknown है उससे नया जानकारी होता है. And this is a cumulative things, no? And then the new information drives to a new unknown. So, and that is the exciting part of science. That if you know all the output, then it is not interesting. I tell about my life also. There should be some uncertainty in your life. Otherwise,
so we have yet not reached to some other kind of radiations which we normally see in our textbooks. Is that you mean?
No, what I mean is so you need to have new instruments or new detectors.
I see. So to identify those.
To first time detect that. So So this multi-wavelength capability, we have infrared, we have optical, we have X-ray, we have near UV. So since you asked this question, this near UV is actually the first time in space for a long period. There were rocket flights, there were balloon flights which had near UV detectors for studying this solar radiation, but for a continuous monitoring in the near UV never happened. So we expect actually from the Aditya mission, we will get new information, particularly the near UV domain with the SOOT instrument. So this is a very, very unique thing. And as you pointed out, you need to continuously monitor. As I said, no, to see the effect of something, long-term changes, you need long-term data also.
Yes.
Just one day's data is not enough. So one good thing about Lagrange 1 mission is also, though it is says it is 5-year nominal life, but we expect to be there at least 10 years. And actually, Narayanan sir, chairman, has told that they have saved enough fuel because of the insertion was so accurately done, they did not have to use too much of fuel. So we should be living in around Lagrange 1 at least 10 years, if not longer.
Yes.
That will be very, very useful to continuously, monitor this radiation, as you rightly pointed out. उसको जितने भी हम लंबा टाइम तक मॉनिटर कर पाएंगे, उसका चेंजेस भी उसको अच्छे से स्टडी कर पाएंगे.
Yes, so one last question, we are running out slightly out of time, but अभी आपने बात की डॉक्टर साहब, जहाँ पर कि हम सन को हर समय देख पा रहे हैं, दिस इज द L1. मुझे याद है प्रोफेसर आदित्य आनंद नारायणन आए थे, उन्होंने बात की थी जेम्स वेब L2 पर. क्या हमारे देश का भी कोई वहाँ पर वो एक ऐसी जगह है जहाँ पर कि तारे नहीं टिमटिमाते, कोई सूरज नज़र नहीं आता, बिल्कुल शेड में है पूरा साइन, तो सो दैट वी कैन सी द आउटर स्काईज, आई मीन आउट ऑफ आवर सोलर सिस्टम एटसेट्रा, एंड दैट हैज मेड आई मीन गुड अमाउंट ऑफ डिस्कवरीज. डू क्या हमारे देश भी कुछ L2 पर जाने का प्लान है?
हाँ जरूर, आपने पूछा तो हम बता ही देते हैं. This is a proposal led by Indian Institute of Space Science and Technology. So IIST along with ISRO and primarily SAC Ahmedabad, we have submitted a detailed proposal to our Space Commission for a mission in L2 and this mission is called ExoWorld. Okay. This is for particularly studying the atmosphere of other planets. Not in our system, but other system. So as I was just indicating that this is the natural question we all have, whether there is life on Earth or anywhere else in the universe. So with that search, even James Webb, which is there at Lagrange 2, what you say, has discovered a lot of new planets. Now to study the planetary atmosphere, you need certain spectroscopic capability. So with this ExoWorld mission, we are actually proposing new instruments to really characterize the atmosphere of these already identified planets. So we are hopefully within a year you will hear the proper announcement that ExoWorld is going to be an approved mission for going to L2.
Yes, we look forward all such details. We look forward all such details to come, and we also look forward having you in our own studios here at New Delhi. New Delhi is very pleasant nowadays. So that's great, sir.
It will be my pleasure. It will be pleasure to come to your studio and interact with your team and tell you more stories about our own space missions.
Yes, sir, we are equally excited. So friends, this was our 108th edition on the webinar series Listening to Learn, where we take up the issues related with the science, technology and society. We seldom move out from the science and technology as well. Now, Harpreet, can we talk about the next?
Absolutely, sir. Very briefly, because it has been a very delightful journey. I would like to thank our special guest for this wonderful presentation, sir. Thank you so much. And now, sir, what's happening in 109th edition?
109th edition. This is on 29th of August 2025. Friends, we will be having Professor S. Natesh from the Department of Biotechnology, Government of India, in our studios here, and he will be talking about on a topic which has been much in demand, that is the speaking tree of Andaman and other iconic trees of India. Lovely. So Dr. Natesh will be with us at the studio, and he will be talking about the iconic trees in general and the speaking tree of Andaman.
That's lovely.
So that will be a lovely session. Looking forward meeting you again on 29th of August, the same time, 10 o'clock. Till then, goodbye.
Thank you so much once again, Professor Gagan Gupta. Thank you so much to our special guest, Dipankar sir, for this wonderful journey. And here we are wrapping up this wonderful webinar series of our 108th edition, where we talked about, of course, National Space Day. Not just talked about, we celebrated National Space Day through our space odyssey to our nearest star, the Sun. And Now wrapping up the session here, very quick information for all of you regarding the textbooks for grade 4 and 7 which are available on Amazon, Flipkart and NCERT website. Please go and purchase your copies from there, and don't forget to share your feedback regarding this session of DESM with us. With this as a wrap, this is me, Harpreet Kaur, taking leave of you. Namaskar.